Hello students. In previous classes we came to know what is the fundamental concepts in organic reactions. Okay, so we came to know what is the substrate, reagent, and what are the intermediates, means between the reactant and products we have intermediate like carbocation, carbanion, isn't it? After that, because of movement of electron, we came to know we have some permanent effects and temporary effects. In permanent effect, we discussed the hyperconjugation, inductive effect, resonance effect. Okay. In temporary effect, we discussed the electromeric effect. Okay. So all these reactions means you came to know what the fundamental concepts. Okay. They were what are the basic concepts. Now let us discuss types of organic reactions. Okay, so in the reactions what are the fundamentals are over. Now we have the how many types of organic reactions are there. Okay, here we have the classification as one we have substitution, second addition reactions, third one we have elimination, and fourth we have the rearrangement. Now let us discuss all the reactions one by one. Now, first one we have the addition reaction. Name itself indicating we are going to add. Addition means add, okay? So, in this reaction, the reagent and the substrate combine together give a single product. Means, here in this, for example, we have the ethene and reaction with the bromine. Okay, this is our what? Reagent, and this is our substrate. Why we are calling substrate means it is giving the carbon CH bond for the product. Okay, now this is called as other than substrate, we are calling as our reagent. Now what happened here? Now here what happened, this pi bond is going to break and two Br molecule, here one Br and another Br going to add together and giving the what? Single product. Okay, so we are going to add together. So we have 1 plus 1 giving the only one product. Okay, here actually we have the two are adding together and giving the single product. So that type of reaction is called as a addition reactions. Here, depending on the reagent added in the slow rate determining step, addition reactions again classified as what? Electrophilic addition reaction, nucleophilic addition reaction, free radical addition reaction. Means here, for example, we have the some H for example, if you add initially H plus, so it H plus means what? It is about electrophiles. So that type of reaction is called as what? Electrophilic addition reaction. Or if you add minus first initial in the reaction, okay, so X minus means what? Negative charge we call nucleophile. If you add the nucleophile first, that type of reactions called what? Nucleophilic addition reactions. Free radical means what? Here for example, here if you go for H dot or if you have X dot, if any one electron is there, that is called what? Free radical. If you add first H dot in reaction, nothing but in a slow rate determining step, nothing but we have the steps. Slow, one step will be slow, that is called what? Slow rate determining step. Okay, so if you add the H dot, nothing but free radical, that is called what? Free radical addition reactions. So this is about addition reaction. Next we have substitution reaction. Substitution means, as you know very well, one is substituted by another one. Okay, so in this reaction an atom or group of substrate species is replaced by another atom or group. Simply you are going to substitute one by another group or one atom. So these are again classified as what? Electrophilic substitution, nucleophilic substitution, free radical substitution on the basis of reagent involved in the determining step. Here simply here we have the OH minus, this is our reagent. Okay, so from here what happened, alkyl minus, here this is a halogen having the more electronegativity, so X minus is leaving and OH minus is going to substitute. So what you are going here, ROH and X minus is going outside. So what happened, X minus is substituted by OH minus. Here what happened, X minus means negative, OH minus also negative. So one nucleophile is substituted by another nucleophile, that is called what? Nucleophilic substitution reaction. Okay, so simply you are going to substitute by another one. So if it is nucleophile, you have to substitute by nucleophile. If it is electrophile living, then you have to substitute by electrophile. Then it is calling as about electrophilic substitution reaction. So for example, here I am taking the, for example, we have the electrophile E plus. Okay, so in this case I am taking the some reagent. So for example, assuming as a Cu. Okay, so now what happened here, this is having the more electronegativity, so you are going to get negative. This is a copper positive. So what happened, this copper is leaving and this electrophile going to attack here. So this is you are going to get the Re and Cu plus came out. So here what happened, one electrophile is going to substituted by another electrophile. So this is example for what? Electrophilic substitution reaction. Now free radical substitution means what? For again you are taking some X that is nothing but free radical. Again here for example Rx is there. Now homolytic cleavage, because of homolytic cleavage what happened? You are going to get the R dot and X dot. Okay, already we discussed. We have the homolytic cleavage, you are going to get the radicals. If it's heterolytic cleavage what happened? You are going to get the carbocation or carbene ion. Now what happened now? This here I will write as this A. Okay, you for clarification this is A dot. Now X dot is leaving and A dot is going to be substituted. So what you are going to get R A plus X dot is came out. Now what happened? This free radical is substituted by another free radical. So this type of reactions called as a what? Free radical substitution reactions. Next we have elimination reaction. Elimination means what? Nothing but removal. Okay. So in this reactions what happened? Two or more atoms or group of inorganic substrates are removed from the multiple to form multiple bonds. Here simply you can see the example here from this. I am going to remove the HX. Okay. So alcoholic KOH means you have to remove the what? One hydrogen and one halogen only, not the two hydrogen. So at a time it's going to remove the bond means what happened? This here we have the single bond is converted into what? Double bond. So you are going to form the one single bond to multiple bond and you are going to remove the what? This is what? HX. Okay, this is what? HX. So going to remove some group of atoms. So that type of reactions called what? Elimination reactions. So you're going to remove. Okay, isn't it? So here we remove and you got the double bond. Okay, so this is our elimination reaction. Simply this is you can write here. So now got the structure like this. Okay, so here because of removal of this bond you got the now double bond here. So this is our product. Next fourth one we have molecular rearrangement. Name itself with what? Molecule undergo rearrangement. Rearrangement means you know very well we are shifting some places. Okay, so here one organic species generally less stable rearranged to another species generally more stable. For example, phase rearrangement. What is a phase rearrangement? Simple here I am taking. For example, here we have hydrogen, here we have hydrogen. Okay, so what happened? This hydrogen will shift here and this entire group will be shifted here. So what happened? You are going to get this product. Okay, so this is I am calling as a orthohydroxybenzophenone. Ortho means what? Here O means one thing but what? Ortho. So in benzene already we told nomenclature. If a substituents at 1-2 position indicate means what? Ortho. So here what happened? This group, entire group came to here and this hydrogen came to here. So simply you went for the rearrangement, isn't it? So it is called what? Orthohydroxybenzophenone. Sometime what happened? Here also we have one hydrogen. Okay, so this hydrogen will shift here and this entire group will come here this side. So what happened? You are going to get this product. Okay, simply you can write this product like this also. This is here. So we got the C here. This group, entire group means some arrangement will be there. Okay, C make it correction, some small correction for the sake of convenient. Okay, this is the group. Okay, this is a group shifting here and this is a group shifting here. So if it is shift here you are going to get this product and from this hydrogen it attached to what? Oxygen here. Okay, so you are going to get the OH. So if it shift here, so what happened? So here we have the hydrogen. This hydrogen will shift to oxygen and this group will come here. So here you can write the structure as such. Here this is C double bond OCH3 and here what you can get OH. Okay, these two structures are same. Okay, this both are same for the sake of convenience. Now it is called as what? Para hydroxybenzophenone. P means what? But para. Why? Because mean in benzene if the substituent are at 1,4 position it is called as a para. So here we have first position and fourth position we have substituent. So that's why it's calling as what? Para hydroxybenzophenone. So what you did here, simply you went for the molecular rearrangement. Simply you are doing the rearrangement here and here. Okay, so this is the example for what? Molecular rearrangement.